Okay, here we are, the last chapter of Intermediate Algebra. 13.1 is the first lesson. It has to do with what are called sequences. And a sequence is, according to the definition, a function whose domain is the set of positive integers 1, 2, 3, 4 into eternity. Alright, so what that means when I say a function, you've done functions, remember? If I have the function f of x equals x plus 1, and I say f of 1, then would be putting a 1 in for x. F of 2 would be putting 2 in for x, etc. Okay, so let's put a few in here. So, and f of 4 equals 4 plus 1 equals 5. Alright, so if I were to ask you the first 4 terms of this sequence, you would give me these 4 answers right there. So the first 4 terms would be 2, 3, 4, and 5, because when I add 1 to each of these numbers, I get 2, 3, 4, and 5. Okay? So, this is going to seem a little confusing at first, but actually sequences are just functions. Like this is a function, f of x equals x plus 1. There's just a function that has a specific domain. Okay, a specific group of numbers that we call x's. Now, those sets of numbers can only be positive counting numbers. Alright, so that should make it easier. Alright, so one of the things that they're going to do is instead of writing f of 1, they're going to write a with a 1 there. Instead of writing f of 2, they're going to write a with a 2. Instead of writing f of 3, what do you think they're going to do? They're going to write that. Okay? So if they give you something like a of n, they're saying we don't at this point know which of these numbers we're looking at. It could be any number. And that's what the n kind of represents, is the number that we're going to use. Alright, so let's go ahead and get rid of all this and look at a couple, and maybe it'll start clicking a little bit. Example 1. Find the first 4 terms of the sequence whose general term is given by a of n equals 2n minus 1. Alright, this can be written like this. I mean, you're used to seeing things like that, right? Or you're used to seeing things like that. This over here is the exact same thing as this over here. It's just written this way to show that we're dealing with sequences. Alright, so nothing really weird or goofy here. It's just kind of the way that they're writing it. So the first 4 terms. So that means that we're going to put a 1 in first, then a 2, then a 3, and then a 4. So that we've got the first 4 terms. So this one is going to be, what did we replace n with here? A 1. So we're going to replace it with a 1 there. And we replaced it with a 2 here. We replaced it with a 3 here. And a 4 here. Okay? So that gives me 2 minus 1 is 1. 4 minus 3. 6, 5. 8, 7. Okay, so there is the first 4 terms of the sequence who has the equation a of n equals 2n minus 1. Okay. Alright, well, let's go on to example number 2. Example number 2 is done the exact same way as example 1. Write the first 4 terms. So again, a of 1 equals 1 over, what are we going to put in for n? A 1. A of 2 equals 1 over, put a 2 in for n. A of 3 you kind of get in the hang of it. I mean, it's not really too terribly difficult, although it will get a little tougher, I promise. It's like, oh great, thanks. I like it when life is easy, right? Okay, so that gives me 1 over 2, 1 over 3, 1 over 4, and 1 over 5. Okay, and that is it for the first 4 terms. All right, let's look at example number 3. And for example number 3, kind of goes a little bit different. Find the 5th and 6th terms of the sequence whose general term is given by. Okay, so we're interested in the 5th and 6th term. We're not interested in A1, A2, A3, A4. We're interested in A5. So we're going to put a 5 in for n. We're also interested in 6. Okay, so that doesn't look too terribly bad. So this equals -1 times -1, da 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 da. An odd number of times always gives you a negative. 5 times 5 is 25. Here it's an even number of negatives, so that's a positive 1 over 36. So there is our 5th and our 6th term. Now, one of the things that makes it a little hard is, let's say sometimes they give you the sequence. Okay, dot 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 means it continues on in that sequence, and they want you to find the function that makes that sequence. See, before I gave you the equation, I gave you something like a of n equals 2n minus 1, and you put the numbers in and got these for answers. Now what they want you to do is start out with the numbers and come up with the formula. Now you'll see this on the SAT and the ACT. They'll do things like this. Okay, so how do I get from 8 to 11, or 11 to 14, okay, or 14 to 17? So that's what we're looking for, is how do I get to those next numbers. So let me just give you the formula. Or they'll write it like this. Okay, so you've got that. Let's see how it works. So if we use 1, we should be able to get 8, because that's our first number, and we get 8. If we use 2, and that gives me 11. So that formula does work, because see, I'm starting to put in 1, 2, 3, 4, and I'm getting the numbers that I had there. There is really no simple, easy way to get the formula, to get this formula right here in order to get the sequence out of it. You just end up having to play around a little bit, and finally it kind of starts coming to you. But that brings us to the next section in this lesson, called the recursion formulas. Okay, so let's go back to this one. And we've got our sequences there, 8, 11, 14, 17. And let's look at something else that happens here. How much is there between 8 and 11? 3. How about here? Also 3. How about here? Also 3. So what we could say, that if we started with 8, and then we added 3, and then took that number, and added 3, then took that number and added 3, we'd still get the same sequence there, right? So as long as we looked at the preceding number and put it here and added 3, we'd get this. Then we looked at this number. Okay, so to get the 17, we looked at the preceding number, the 14, and added 3 to it. Okay, so each term can be found by adding 3 to the preceding term. Okay, so we added 3 to the preceding term, 8. We added 3 to the preceding term, 11. We added 3 to the preceding term, 14. So if we start with 8 and then add 3 to each term, we'll get the next term. So this is what that looks like. So let me get rid of all this stuff here. I'm going to leave that there. So we have, if my first number answer is 8, if I take a of 1, well, if I already said a1 equals 8, but if I said that the next number is going to be the preceding number, and the way you write the preceding number is that the number you're looking at minus 1, and then we add 3. Okay, so when I had my 8, and then I had my 8 plus 3 equals 11, and then my 11 plus 3 equals 14. I'm just kind of rewriting it here off to the side so you can see what happens here. This number right here is the preceding number. It's whatever the number we're on minus 1. So if this were the first number, the second number, the third number, the fourth number, and we're looking for this one, a to the fourth number, which we know to be 17, is going to be a to the 4, because that's what we're looking for, the fourth number, minus 1 plus 3. So it's going to be a to the fourth equals a to the third. What is the third number? 14 plus 3. So a to the fourth is going to be 14 plus 3 equals 17. So the hard part is this thing right there. This is whatever this number is, this minus 1. So if this number were 4, like here, the fourth number, it's not the answer, it's the fourth number. 4 minus 1 is 3, so now we go up to the answer to the third number, which is 14, add 3. If this were if we were looking for the second number, it would be the second number minus 1, which is the first number, and the first number is 8. 8 plus 3, and that would give me 11. So if this is 2, a to the 2 equals the one before it, which is 8, plus 3 is 11. So that would be that one. So probably the thing that gets students confused is, what is this number and what is this number, these numbers here? Alright, the n always represents not the answer, but which consecutive number we're talking about. Are we talking about the first, the second, the third, the fourth number? So if you just remember that n, you always say first, second, third, fourth, fifth, sixth, you're going to be safe. That'll remind you that this is not the answer. This is which number we're talking about, first, second, third, fourth, fifth. So if I'm talking the third number, it's 14. The fourth number is 17. The fifth number then would be 20. Okay? So this n just represents which number we're talking about, not the number itself. Alright, so let's go ahead and stop this video and continue on with 13.1b as in boy.